Hello, everyone. Welcome to our team's presentation on changes in the Earth's rotation, shadows, and the constellations. As many of you may know, Earth makes a full rotation around the Sun every 24 hours. Half of the Earth is facing the Sun, while the other half is not. This splits the Earth into day and night. However, the Earth is actually tilted at 23 degrees. This is why some places have different amount of sunlight depending on the Earth's tilt. This also explains the seasons of the Earth.
And we'll use the flashlight to simulate the Sun. Now the Earth is to the west of the Sun, so let's take this as example. Now the northern hemisphere is experiencing summer. The sunlight is straightly irradiating this line, which is called the Northern Tropical or the Tropical of Cancer. And probably you might notice that the length of the circles of latitude in the northern hemisphere to the terminator, which divides the Earth into daytime and nighttime, is actually much longer than that in the southern hemisphere. So we say that the northern hemisphere is experiencing summer with longer daytime hours, while the southern hemisphere is now winter with longer nighttime hours. Also, another point you might notice is that this region of the northern hemisphere is always facing towards the Sun at this position. This is the Arctic region, and this phenomenon is called polar day. However, on the other hand, the South Pole is in total darkness. It is called polar night. And the equator is kind of in the middle, so it actually has approximately equal amounts of daytime and nighttime.
What are shadows? There are many light sources on Earth, such as lamps, flashlights, and most importantly, the sun. Shadows happen when objects are in the way of light's path. They are basically an absence of light. Shadows are based on the position of light. The smaller the angle between an elongated object and the direction the light is, the shorter the shadow is. On the other hand, the smaller the angle between the direction of the light and the surface on which the shadow occurs is, the longer the shadow is. Let's see an example. In this example, the flashlight is mimicking the sun, and as it moves, the shadow of the object moves as well.
Before we move on to the idea of groupings of stars, I think it's important that we have an intrinsic idea of patterns. Put this against the context of the times we live in. We live in a world controlled by seemingly complex and confusing mechanisms. However, as mankind progressed through generations, we've come to make sense of these mysteries. Ask yourself exactly how. The answer to that is science. We look at the world through the lens of science, through analysis, through exploration, and through idea building. And we try to bring chaos and order. We try to bring order to this chaos we struggle with. This is the basic idea of patterns. They imply repetition or intelligible design that can be interpreted by humans meaningfully. Examples are on the right. Then you have the idea of constellations, patterns that go beyond Earth. If there are patterns on Earth, then there must be patterns outside of Earth. This manifests as groupings of stars. That's exactly what constellations are. Groupings of stars that seem to form a distinguishable pattern when viewed from a particular position on Earth. This wording is important, especially the last bit. This is why. As Huang mentioned, orbits of the Earth around the Sun and the Moon around the Earth, together with the rotation of Earth about an axis between its north and south poles, create results, namely observable patterns that often change for different times of the Earth. Notice how at a particular time there is a side of the Earth facing Orion, and at a different time, the side is facing Leo. At one point of the year, people on Earth are looking out toward one direction in space. A couple months later, those same people are looking at a different part of space. Because these stars don't travel with us and are spread across the bounds of the universe, we see different constellations at different times because it's only the Earth that's rotating on its own axis. How do we observe these things? Simple. 4 steps. Find a spot with complete darkness. A lot easier said than done. A flashlight so you don't injure yourself. A pair of handy binoculars and a star map. A star map is important because it helps put all constellations in relation to one another, so you can pick at them a lot easier. Sample results. So this is what you would see if you're looking south at about 8 p.m. from middle northern latitude, such as most of the US and southern Europe. Note the location of the Castor-Pollux Gemini constellation. It's important. Notice how now that same grouping of stars is now on the right-hand corner, even though we're looking at the same point. This is a different time period, so that surely shows that there must be some shift. And since stars themselves don't shift, it must be because of the rotation on the Earth's axis. Once again, July, we can see different constellations that we probably couldn't see before at a different time of the year. Then there's the August sky overhead. Once again, the constellations look a bit different. This is just because we've changed our point of perspective from south to overhead. And then you have the final picture, which sort of unites the whole idea together. It's independently, these pictures wouldn't make a lot of sense, but once you put them together, you can see if you look at the sky from different points, constellations themselves look a bit different. If you combine all the images together, it makes a complete star map. So that wraps up our presentation. We hope you've understood that certain complex things like shadows and stars are explained by really simple scientific principles, and we can understand these principles because of the patterns that we can observe. Thank you.